Today in this video we will see chapter 6, which is lines and angles. The definition given by Euclid's line is defined as a breadthless length. Okay, what is meant by this is, let's take a rectangle. A rectangle has length and breadth here. Now if we say a length without breadth, that means a breadthless length, it will be only this one. So this is the definition given by Euclid. Now angles are formed by two rays having a common point. Now these two rays are both originated from this point, like this, and now there is an inclination here, so this inclination is what we call angle. Now these two rays are called arms. Now we have three angles. Now among these three angles, the inclination made by these two lines, the inclination here is the smallest and the inclination here is bigger than the first one, and the inclination here is the biggest one. So we say that this is the smallest angle and this angle is bigger than the first one, and this third angle is the biggest angle. Now let's see types of angles. Okay, the first one is acute angles. Now acute angles are those angles in which the measurement is less than 90 degree but greater than 0 degree. Now x is greater than 0 but less than 90 degree. So such type of angles are called acute angles. And now next type of angles is right angle. Okay, it is a type of angle in which the measurement is 90 degree here. An angle whose measurement is 90 degree is called a right angle. Now the third one is obtuse angle. Now obtuse angles is a type of angle in which the measurement is greater than 90 degree but less than 180 degree. Example, let's say 120 degree. So it should be less than 180 degree but greater than 90 degree. So any angles is called an obtuse angle if it is greater than 90 degree but less than 180 degree. Now next is straight angle. Now if both the arms forms an opposite rays, that means a straight line, then this angle will have a measurement of 180 degree. So such type of angle is called a straight angle. Next is reflex angle. Now if an angle has a measurement of more than 180 degree but less than 360 degree, then that angle is called a reflex angle. Example is, let's say this is 210 degree. So reflex angles are those angles whose measurement is greater than 180 degree but less than 360 degree. Greater than 180 degree and less than 360 degree. Now let's see collinear points. Collinear points. Points lying on the same straight line are said to be collinear points. Let's take some points here. Let's say this is A, B, C, D, E. Now all these points, as you can see, lies on this same straight line. So such points are called collinear points. Now if the points are not on the same line, if the points are not lying on the same straight line, then those points are known as non-collinear points. Non-collinear points. Next, let's see intersecting lines and non-intersecting lines. Intersecting lines are those lines which have one common point. So these two lines have a common point here. So we say that these two lines are intersecting lines. That means they are intersecting at this point. Now if we say non-intersecting lines, it will be a parallel lines. Parallel lines. Now if two lines are such that they do not intersect, are known as parallel lines. Okay, now let's see pairs of angle. Pairs of angles. Pair of angles. Adjacent angles. Now if two angles are such that they have a common point, that means they have a common vertex and they have a common arms. Now this middle line is now this middle line belongs to both these angles. So this is the common arms and these are the two non-common arms. Then these two angles are called adjacent angles. Next is linear pair. Now if two adjacent angles are such that the two non-common arms forms a line. Here this line, this arms and this arms for this angle and this arm for this angles, they are opposite rays now. And the sum of these angles will be 180 degree. So such pairs of angles are said to form a linear pair. Now let's go to axiom. Okay, through two given points, there is one and only one line passing through them, through the two given points. Now this is something which we don't need to prove to be true. So this is a universal truth. So such statements or such properties, such property is called axiom. Now the first axiom given in the chapter is, if a ray stands on a line, then the sum of the two adjacent angles formed is 180 degree. Okay, so the first axiom given in this chapter is, if a ray stands on a line, now this is a line and let's draw a ray here, then the sum of the angles, two adjacent angles formed is 180 degree. which means this angle plus this angle is 180 degree. Now this is obviously true because this is a straight line, and we know that the straight angle is 180 degree. So if you add these two angles, you will get 180 degree. So this is the first axiom given in the chapter. Now the second axiom is the opposite of this. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. So here we have two adjacent angles. This is one angle and this is another angle. Now this is their common point, that means that is common vertex. Now since this is a straight line, we know that this too will be 180 degree. But what the axiom says is, we don't know whether this is a straight line or not, but the sum of these two angles is 180 degree. So if it is like that, obviously these two rays must form a straight line, otherwise the sum of the measurement will never be 180 degree. So this is what the statement says. The second axiom says, if the sum of the angles of the two adjacent angles is 180 degree, then the two non-common arms forms a line. Now next is theorem. Now the difference between theorem and axiom is, axiom are those properties which we don't need to prove to be true, but theorem is something which needs to be proved. The first theorem in the chapter is, if two lines intersect each other, then the vertically opposite angles are equal. So here, let's say these two lines intersect at this point, then this angle and this angle are known as vertically opposite angle, and these two are equal. For example, let's say this is 80 degree, then this will be also 80 degree. And now this angle and this angle are also equal. These two are also vertically opposite angles. If this is 100 degree, then this will be also 100 degree. Now to prove this, we're going to use the properties of linear pair. Now here, this being a straight line, let's say this is 1 2 3 4, being a straight line, and this is a ray standing on this straight line, so the sum of these two angles must be 180 degree because they are linear pair, they form a linear pair. So angle 1 plus angle 2 is equal to 180 degree. This two, and angle 2 and angle 3, let's say angle 1 and angle 4 again forms a linear pair because this is a straight line, and here is a ray, and this ray is standing on this straight line, so the sum of these two angles will be again angle 1 plus angle 4 is equal to 180 degree, linear pair. Now from these two equations, right side and right side are equal, that is 180 180, so left side and left side must be also equal. Angle 1 plus angle 2 will be equal to angle 1 plus angle 2 is equal to angle 1 plus angle 4. Now we cut this angle 1, we have here angle 2 is equal to angle 4, which is this angle and this angle. So in the same way we can prove this angle 3 and angle 1. That is the first theorem given before exercise 6.1. Now we will see exercise 6.1. Now this is exercise 6.1, and for the MCQ portion of this chapter I will be making a separate video for that, so make sure that you don't miss that video. Now here we are going to see the non-MCQ questions. And the first question is, in the given figure, lines AB and CD intersect at O. Okay, this is line AB and this is line CD, and they are intersecting at O. If angle AOC plus angle BOE is equal to 70 degree, now AOC is this angle and BOE is this angle, so the sum of these two angles is 70 degree, and angle BOD is equal to 40 degree. Angle BOD is 40 degree. Now this is 40 degree. Find angle BOE. We're going to find out this angle, and reflex angle COE. Okay, this is angle COE, and when we say reflex, then the back side of this angle COE, so that is the reflex angle. Now let's draw this portion here. Here we have a line AB, and this ray is this one. Now we have three angles here, this angle, this angle, and this angle. Now these three angles are on this straight line, so the sum of this angle plus this angle plus this angle will be 180 degree. So solution, I'm going to write angle AOC, plus, I'm going to write this angle and this angle, BOE, plus this angle COE, is equal to 180 degree. The reason being, angles on a straight line, angles on a straight line. Now this angle plus this angle, as it is given here, it is 70 degree. So angle AOC plus angle BOE is 70 degree, plus angle COE, this is equal to 180 degree. Now we transpose the 70 to the right hand side, we get COE is equal to 180 degree minus 70 degree. Now after subtraction we get 110 degree. So reflex angle, therefore reflex angle of this angle COE will be 360 degree minus angle COE. Now this is, to find reflex angle, it is very simple. Let us suppose that this is angle ABC, whose measurement is 60 degree. Now we know that the measurement of angle starting from this point back to this point is 360 degree. So this is a complete angle which is 360 degree. Now since we already know this portion, this angle which is 60 degree, now we can find out this backside angle which is reflex angle of this angle ABC. So reflex angle is nothing but reflex angle ABC will be equal to 360 degree minus angle ABC, which means 360 degree minus 60 degree. Now this is equal to 300 degree. So this is 300 degree. So this is what we have done here. Reflex angle COE is equal to 360 degree minus angle COE. So this will give us 360 degree minus 110 degree. Now this is 250 degree. So reflex angle, this part we have got here 250 degree. Now we have to find out angle BOE, this angle BOE. Now to find this angle BOE, again we are going to consider this line CD, this line CD. Now this OB I'm going to throw here. This is O, this is B, and OE is this line. Now since this CD is again a straight line, so whatever we have angle here, the sum of this angle will be again 180 degree. So again we will write angle COE plus angle BOE plus angle BOD is equal to 180 degree. The reason is angles on a straight line. Now angle COE, this angle is this one, 110 degree, plus angle BOE, angle BOE, this is 110, and this is what we are supposed to find out, BOE. And BOD, as it is given in the question, BOD is 40 degree. BOD 40 degree. Yeah. So angle BOE plus angle BOD is, this angle is 40 degree, is equal to 180 degree. Now 110 plus 40 is 150. Angle BOE, this is equal to 180 degree. Now again we will transpose BOE 150 to the right hand side, so this plus is now minus 150 degree. Now angle BOE is equal to 30 degree. 180 degree minus 150 is 30 degree. So we have got now COE, which is 110 degree, and BOE, which is 30 degree. Now that is the answer for this question, first question. Now let's see question number 2. In figure 6.16, lines XY, this is the line XY, and MN intersect at O. This is the line MN, and this is the point of intersection. Now these two lines are intersecting at point O. If angle POY is equal to 90 degree, POY, this is 90 degree, and the ratio A is to B is equal to 2:3, find C. C is here, so we're going to find out this one. Now solution. Now these two are perpendicular lines. Now if we have 90 degree here, then obviously the other angle will be also 90 degree. The reason is, now these two angles are on this same straight line, so these two angles forms a linear pair. So if you add these two angles, you have to get 180 degree. So now if this is already 90 degree, then the other one should be also 90 degree, because 90 plus 90 is 180 degree. So that is what we're going to say here. We have angle POY is equal to 90 degree, or else you can show like this: angle POY plus angle POX is equal to 180 degree, because like I said, these two angles forms a linear pair. Now this angle POY is 90 degree plus angle POX is equal to 180 degree. Now angle POX is equal to 180 degree. You transpose this 90 to the left hand side, then we get here 90 degree. Now this is angle POX equal to 90 degree. So angle POX is 90 degree. Now this POX is made up of two smaller angles, that is POM, which is A, and MOX, which is B. So if you add this A and B, then we get this big one. So A plus B is 90 degree. Therefore you can write here A plus B is equal to 90 degree. Now let's take A is equal to 90 degree, B transpose to the right hand side, so we get here 90 degree minus B. Now the second thing that is given in the question is this ratio, A is to B is equal to 2 is to 3. So we're going to use that one. Now A is to B is equal to 2 is to 3. This one we can write A by B is equal to 2 by 3. Now if we cross multiply here, we get 3A is equal to 2B, and then dividing both sides by 3, then we get here 2B by 3. Now let's call this 2. Now if we compare these two equations, this one and this one, here A is equal to this one, and here in the second equation A is equal to this one. So since both these are A, now these two right hand side must be equal. So we can say here now we can say from 1 and 2, from 1 and 2, from 1 and 2 we get, from 1 and 2 we get 90 degree minus B is equal to 2B by 3. 90 degree minus B equal to 2B by 3. Now again we will cross multiply here, 1 in the denominator, so 3 into 90 is 90 into 3 is 270, minus B into 3 is 3B. Now 1 into 2B is 2B. Now let's take 2B to the left hand side, and this plus change to minus, and also this 270 to the right hand side, so plus becomes minus. Now minus 3B minus 2B, B is 5B, minus 5B, this is equal to minus 270 degree. Now here we can cancel this minus minus, so what we get now is B is equal to minus 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 already cancel out, so now we have 270 degree by 5. Now we can cut this, B equal to 5 ones are 5, 5 fives are 25, 2 remainder here 4, so 54 degree. Now B is 54 degree. Now this is 54 degree. Now what we're going to do now is we're going to consider this line MN. This is MN, and this ray, this one, this OX. O is here, this is X. Now this is a straight line, so these two angles forms a linear pair. So this is a straight line, these two angles forms a linear pair, so the sum of these two angles will be 180 degree. So angle MOX plus angle XON is 180 degree. So now angle MOX plus angle XON is equal to 180 degree. Again, the reason is this two forms a linear pair, and this is B, this is C. So we have here MOX is B and XON is C. This is equal to 180 degree. Now B is 54 degree plus C is equal to 180 degree. Now what we got here is C is equal to 180 degree, 54 transposed to the right hand side, 54 degree minus 54 degree, so we get here 126 degree. So this is our answer. Now next question, that is question number 3. In this figure, PQR, angle PQR is equal to angle PRQ. Now PQR is this angle, is equal to angle PRQ, this angle. Now then prove that angle PQS is this angle, is equal to angle PRT. So this is the angle. Now what we're going to do is we are going to prove that these two angles are equal. So here to prove is angle, this one, angle PQS is equal to angle PRT. Now let's see how to prove this one. Now here also we are going to use the property of linear pair. Now this is a straight line, and since this is a straight line, the sum of these two angles will be 180 degree, this one and this one. So this property is what we call linear pair. Now here we have, okay, let's write this one. Angle PQR is equal to angle PRQ. This is given. Let's call it 1 here. And now angle PQS is this angle plus angle PQR, this angle. These two are, the sum of these two angles is 180 degree. So let's write that one. Angle PQS plus angle PQR is equal to 180 degree. This is linear pair. Let's call it 2. Similarly, on the other side, this angle and this angle forms a linear pair, this being a straight line. So the sum of these two angles is 180 degree again. So angle PRQ, which is this angle, plus angle PRT is this angle. PRT, this is 180 degree. The reason is being linear pair, so we're going to call this equation 3. Now from this two equation, that is equation 2 and equation 3, we get here from 1 and 2, from 2 and 3 we get right hand side being 180, this left hand side will are equal. Angle PQS plus angle PQR is equal to angle PRQ plus angle PRT. Now as given by the first equation, which is angle PQR equal to angle PRQ, Now we can get PQR and PRQ using one. So finally what we got is angle PQS is equal to here and here, angle PRT, which is what we are trying to prove. So hence proof. Now moving on to next question. Now question number 4. In this figure, x plus y is equal to w plus z. Then prove that AOB is a line. Okay, to prove is AOB is a line. Okay, here we have 4 angles, x, y, z and w. Now according to question, x plus y is equal to w plus z, these two. The sum of these two angles is equal to the sum of these two angles. So let's write here x plus y is equal to w plus z. This is given. Here the sum of these 4 angles, that is x, y, z and w, the sum of these 4 angles is will be 360 degree, because we know that these 4 angles forms a complete angle. So like this. Now if you measure the angle from here to here, then we will get here 360 degree, which is known as complete angle, which is called complete angle. So these 4 angles forms a complete angle from here to this point. So here we will write x plus y plus w plus z is equal to 360 degree. The reason being these 4 angles forms a complete angle. Now x plus y plus this y, w plus z, these two quantities are equal. So in place of this w plus z, I'm going to replace it with x plus y. So x plus y, this is equal to 360 degree. Now here we have x plus x, 2x, y plus y, 2y. This is equal to 360 degree. Now we can take 2 common here, and 2x divided by 2, 2x divided by 2 is x, again 2y divided by 2 is y. This is equal to 360 degree. Now dividing both sides by 2, we get x plus y is equal to 360 degree by 2. Now x plus y is equal to, cut this, so we get here 180 degree. Now what we got here is this angle plus this angle is 180 degree, which implies that this line is a straight line. This AB is a straight line, AB, which is AOB. This implies that AOB is a straight line, is a straight line. Okay, this is our proof.